Hi everyone, thanks for giving me this opportunity to participate and share my research in this conference. Let me introduce an interesting topic related to high voltage area to you, which is the finite elementary analysis of electrical performance of glass-type insulator under the inclination effects. So I'm an author today to present in this conference, Mr. Ting Yan. Beside that, we also have the other authors, Associate Professor Dr. Shamshul, and also the Dr. Amizah is participate in the research. Allow me to share the research by starting with a brief introduction on the transmission system and the insulator. Practically, the transmission system is functioning to carry the electrical energy from the generation to the user. The reason we transfer the electrical energy in high voltage is to reduce the power loss. Theoretically, as we know, P equal to I squared R. When we increase the voltage, it will reduce the current so that we reduce the power losses in the transmission system. With this, only the user can get the maximum efficiency of the electrical energy to reduce the voltage. That's why the insulator is playing a very important role to provide the insulation support and also the mechanical support to the transmission tower. This is because the overhead cable do not have the insulation layer. If the cable is touching to the tower or the ground will lead to the flashover and damage of the system. So insulation string is mainly composed by the glass disc. In this research, we will focus on the 132 kilowatt of glass insulator, which consists of 8 peak of the standard metal cat and pin type of insulator. So the glass insulator is focused in this study and chosen in this study is because the popularity and widely used in the transmission system, especially we can see in Malaysia. Beside the glass insulator, we also found the ceramic type of insulator, composite insulator, polymer insulator, and etc. In the insulation space required, it is highly dependent on current distance and prepared distance of the insulator. So this distance will highly determine the electrical performance of the insulator. Although the glass insulator is reliable, but the problems or challenges comes when the insulator suggested to outer environments. The first is the pollutions. Generally we have a four types of pollutions, which is the industrial pollution, marine pollution, diesel pollutions, and biological pollutions. From this, the contamination surface of the insulator may create a conductive path to cause the flashover of the insulator. Besides that, we also have the lightning, wind load, and also the climate change give a significant impact to the insulator. In this research, we will focus more on the wind load actions of the insulator. This is because the high wind speed will shrink the insulator and lead the inclination of the insulator. If the insulator do not have a proper maintenance, it will cause the aging of the insulator. Thus, the drop of electrical performance may increase the risk of flashover or arcing. Flashover of the insulator will cause a breakdown in the transmission system. As mentioned previous, the wind load action of insulator will cause the swing of the insulator. It creates the inclination effect to the insulator. For your information, the average wind velocity recorded in Malaysia is between the 32.5 meter per second to 33.5 meter per second, and it recorded in 10 meter height. Also, the maximum wind speed recorded in Malaysia is 41.7 meter per second in Kuching, Sarawak. From the diagram, we can see that the possible swing angle from previous research is considered in this study, which is from 0 degree to 45 degree. When the insulator is swings, the reduction of current distance will increase the possibility of the flashover of the insulator. In addition, the wind speed is increasing with altitude. The transmission tower or insulator located in the high area will suffer the higher wind speed compared to lower altitude. In modeling part, the software ICSET is used for this simulation. The insulator model is drawn by using the AutoCAD by follow the manufacturer standard. We can refer the table. The table shows the standard parameter for the metal cat and pin type insulator, and the diagram is referred to the 3D model in AutoCAD. So after that, the model for the AutoCAD is import to the ICSET, and the finite elementary modeling is conducted by using the Matchplot for computerized calculation. In result and discussion part in the research, the electric field distribution across the glass states is analyzed. We can see from the diagram, the electric field distribution across the symmetrical red line is studied for every pieces of the glass state. It follows the position. The glass state number 1 is nearest to the cross arm, represent to the ground, while the glass state number 8 it crosses to the high voltage arm. At the right, the results show the glass state number 8 has the highest electric field distribution, meaning to say, the glass state number 8 is the critical part of the insulator experience the highest electrical stress. In each of the glass state, the joint between the metal cage and glass has the highest electric field. So the localize of the electric field is because the difference is the electric permeability of different material. Therefore, the higher electric field will be distributed at this particular area. This slide shows the counterplot diagram of the electric field. The red color refers to the intense electric field and the blue color shows the less electric field distribution. So from the diagram, when the insulator inclines even for 15 degrees, the intensity of electric field starts to spread in surrounding. We can observe that the condition is getting worse when the insulator inclines out to 45 degrees. The high electric field in surrounding may create the flashover part if the electric field is higher than the breakdown value in air. This condition gives the high impact to the insulator and reduce the insulation level and also the electrical performance. The electric field distribution along the insulator also considered in this study. In the vertical condition, which is a 0 degree inclination, the electric field is observed in metal cage area only. However, when the insulator inclines, the electric field increases also in glass area. From the result, the possibility of arching and flashover likely to happen very high in this case. In overall, the electric field also increases in all areas for insulator when the insulator is inclined. This result justifies the significant impact of the inclination towards of the insulator. In summary, this research has focused on insulation strength of the glass insulator under the different inclination conditions by using the finite elementary analysis, which using the software as well, and also the glass near the high voltage arm, which is this number 8, has the highest electric field distribution compared to other discs. So we also found that the vertical insulator without the inclination effect, the electric field is focused on the metal cage and pin area only. When the insulator inclines, the electric field is distributing to the glass. It may create the conductive path to the insulator. This is my sharing for today, and thank you for your time. Thank you.